this is part of a very long-term project to build a radio-controlled Wellington using the same method of manufacture, i.e. geodetic channel. I started with the turrets because the problems involved in reverse engineering the fuselage structure of the Wellington are not trivial, and by starting with this it gave me more time to think about the airframe itself. This was a more straightforward proposition.
So it's a Fraser-Nash turret, is it?
Yeah, this is an FN5, which was the predominant early war turret in Wellingtons. Once the Vickers gun positions, which were non-traversing, once those were superseded, this was what the Wellington had for the remainder of the war in the case of the front turret. In the rear turret, this changed in the Wellington Mark III to a 4-gun turret, which was known as an FN20. Again built by Fraser-Nash. These models are 1 to 4.5 scale, and when complete, this will obviously all be glazed with very thin perspex, and will be capable of motorised traverse. As you can see, the elevation and depression, which is pneumatically operated, works, and that will be a servo operating a high pressure air source to power that. The gun sight works. It's a fully functioning collimating gun sight.
So Tim, what do we see here? So that's the front turret, is it?
This is a tail turret, as it happens,
okay,
but
right.
so this is for a Mark 1C Wellington, therefore it's still got the 2-gun rear turret.
What will be the difference between a front and a rear? Is that the front?
There's virtually no difference. The only difference is that on the rear turret, the shell cases go to a single unified pipe at the bottom, whereas on the front turret they stay as 2 separate chutes.
Okay.
There are 1 or 2 extremely minor differences that aren't there, but they're very subtle. You'd almost not see them.
Okay.
This is a tail turret. This one, it's got the single unified joint down there.
Okay.
And a different handle here, but otherwise the 2 turrets are the same.
So what is the single unified joint?
This bit down here,
what does that do?
Well, as the cases are caught by these chutes, they're routed down here, and they simply fall out the bottom onto the floor.
Okay.
And then the gunner had a trapdoor that he could press with his foot, which would vent all the cases out into slipstream. Couldn't do that with the front turret, because if he did, of course they'd all hit the engines and the fabric on the wings and the fuselage and do all sorts of damage.
Yeah,
so in the case of the front turret, the cases were essentially wound up in canvas bags. And I haven't finished the bowl, the bit that goes underneath the turret, which is different to this one. And on the front turret there was an access point at the back. You could open up the canvas, reach in and pull these bags out. So you've got the seat, which rises up and down in slots. On the real aircraft, these handles here would pull back and therefore could be rotated to adjust the seating height for the gunner. Taken about 4 years to
get to this stage.
They're about 98% complete now. It's just the windows to do, and then they're done.
So the scale is just over 1 to 4.
Yeah, 1 to 4.5. And the scale was determined by the availability of engines to power the aircraft, because once you start looking at big radials, there's not many about, especially 9-cylinder radials. So essentially I matched the scale to the available engines on the market to power it.
So in the sense of 1 to 4, what is the actual length of the fuselage that you're having to work
15
with?
feet.
Okay.
And the wingspan will be about 19 feet. I forget, it's so long since I looked at it, I can't remember.
No, but that gives us an idea.
Yeah.
And where are you building it?
in my garage.
Okay.
So I've built a jig for it so that I can work on any aspect of the aircraft, lock it off to work on, rotate it if I need to be, and without having to take the thing out of the workshop, turn it around and bring it back in. I can just work on it on any angle, and that will do for the wings as well.
So how many more hours of work do you think you've got here?
I don't know, hours. Well, actually, it's going to be a bit fiddly, a couple hundred maybe.
Right, okay.
Because the when I've done the windows, they'll be done as vacuum formed plastic over a mould, and it's the mould that I'm looking at building at the moment. And then all the these holes here and these tabs here will need to be bolted through the plastic, so it'd be a long and slow job.
And will you do that concurrently with the starting of the work on the fuselage?
No, I'll finish these before I even look at the fuselage, I think.
And will the fuselage be the next job to start to build?
Yeah.
Okay.
So I'm quite looking forward to that because it's been just completely immersed in turrets the last 4 years.
Yeah.
Right, the first thing I'll be doing is building some prototype shapes with specific curvatures to make sure that I can fabricate it, and then testing those to destruction to see how resistant they are to vibration and so on. And then I'll take a decision about whether or not to proceed with the rest of the airframe as planned.
Okay.
It may be that we decide not to build it as a flying aircraft, but just to build it as a large static model.
With moving
I
bits,
used to tease my wife that I'd hang it on the ceiling in the lounge.
So this isn't your first venture, presumably. You've done others, but not as of this level?
No, this is, I've taught myself computer-aided design, then 3D printing. I did an O-level in technical drawing 40 years ago, and I have some experience with working on motorbikes. I mean, I've had some failures. This is the first RAM that I built. And that's got a tiny electric motor in the bottom and then a reduction gearbox that drives a lead screw that causes this to come in and out. It does work, so it's essentially a homemade linear servo, but it lacked the power, especially as I could only use one of them, because if you have two you have to get the signals working so that the thrust is equal.
Right.
I couldn't do that, therefore I was restricted to using one, and when you did one it just twisted enough to bind, and that was more than the motor could cope with. So I had to bin that and change to a pneumatic system. So these have underneath this plastic cladding there are little pneumatic, double-acting pneumatic cylinders. But there's nothing magical in this. It's just a matter of just being really obsessive about the detail.
Yeah.
I think the hardest thing to do was to work out. You'll see that as it elevates and traverses, the gun sight remains parallel to the guns. So, there's a lot of geometry involved in that because the linkage, if you look at it from the side, the ram pushes this here, which is arm, has an axle that comes through here, so that as the axle turns it raises this arm which pushes this rod which acts on the cam at the top, and all that geometry has to be correct for the gun sight to remain parallel to the guns, and that was a bit of a headache, to say the least. But we got there in the end.
Incredible work.
Both move slowly.
Fascinating.